Okay, kids, so this next lesson's very straightforward. It actually works out very well to do this just on a video. I don't think you're going to have too much difficulty with this. You see the heading is detours and rat. I'll explain what rat is in a little bit. We've actually already been doing detour proofs for a while, right? Remember, a detour proof is when you prove a set of triangles congruent, and then you take information from that to then go ahead and prove another set of triangles congruent. So you have to take a little bit of a detour, all right, to get to where you want to go. Now, I'm not going to do this proof here. I think you can do this yourself. I was not the author of this particular document. I would have normally, well, no, actually, yeah, this is just a fill in the blank proof. You can go ahead and mess with this. I've already posted the solutions on Canvas, so if you get stuck, you can check the solutions. All right, I'm going to get into the lesson. The lesson's pretty straightforward. And let's face it here. If we prove, and I've already talked with some of you about this, let's say we prove that these two triangles are congruent, okay? And let's say we proved it through, it doesn't really matter. We got this reflexive piece. Let's say we proved it through SSS, all right? Well, if we prove that those two triangles are congruent and we got it through SSS, what do we know about these two angles here? Well, we know that those angles are congruent then because of CPCTC, right? But we also know, based on the original diagram, that these two angles add up to a straight angle. So if these two angles are both congruent and they add up to a straight angle, doesn't that mean that those two angles both have to be right angles? Of course it does, right? So complete the following theorem. If two angles are both supplementary and congruent, then they are right angles. Okay? So that is the new theorem of the day. Not that big of a deal, is it? All right. I'll do, a proof or two here, and just to kind of quickly go through it. Again, saving time, starting with step 2, XR bisects YXZ. That's an easy thing to forget. So I'm going to catch up with my tick marks right away. And I'm going to say angle YXR is congruent to angle ZXR if seg bisects an angle, then divides it into two congruent angles. And then, of course, we have, well, there's a couple different ways we can do this, right? We could say if angles and sides, and then do ASA, we can do reflexive. It doesn't really matter. I'm going to say XR is congruent to XR. And that will be reflexive. So that leads us to angle side if we do it that way. So we have triangle XRY congruent to triangle XRZ. And of course, from that, we're going to state that angle XRY is congruent to angle XRZ by CPCTC. And we know that those angles are also supplementary. Angle XRY is sup to angle XRZ. If sum of two angles straight angle, then sup. And now we finally use the new thing that we discussed, angle. Now we have to show state that one of these is a right angle, honestly. Angle XRY is, whoops, pen's freaking out there. Let's fix that. Angle XRY is a right angle. If angles sup and congruent, then right. And this is going to be a 6-step proof, right? XR is then an altitude if segment from vertex of triangle forms right angles with opposite side, then an altitude. I just noticed on my key, I missed a step. I forgot a step. I forgot that bisection showing these angles are congruent up there. So this is correct. What we just did, 8 steps. The document that I posted will be missing a step. So just so you're aware of that. Okay. So I don't think this really. I mean, that's it. If angles are sup and congruent, then they're right. So, you know, that's not really that big of a deal, right? So on the back side, first of all, you see here, this is messed up too. You got the same exact problem twice. I don't know what happened there, but so just cross out this second one. That's the same thing as number 3. I'm going to quickly go through number 3, but you should be able to do this yourself. I have 8 steps for this. PQ bisects YZ. Sorry, YZ. Q is the midpoint. Down there, we have angle Y congruent to angle Z. We have WZ congruent to XY. So, we have to be careful. We have to make sure we catch up with the tick marks. ZP congruent to PY. Remember, that's because of bisection, right? If segment bisects segment, then divides segment into 2 congruent segments. Okay, so I can actually say that these triangles up here now are congruent, right? Triangle ZPW congruent to YPX. And that's, of course, by SAS. My pen is just very unhappy here. Now, we look at what we have to prove. We have to prove that these angles are congruent down here. Not going to be that hard of a thing to do. Okay. Let's see. What are we going to take from CPCT? We're going to take PW congruent to PX. And that's, of course, CPCTC. And then, and then I can do a reflexive step PQ. Now remember, I forgot to say, I have not said that WQ is congruent to QX. And that's because of midpoint, right? If point's midpoint, then divides segment into 2 congruent segments. Now we finally have those lower triangles, triangle PWQ congruent to triangle PXQ, and that's by SSS. And then, of course, we finish with CPCTC. Okay. Angle WQP is congruent to angle XQP. And we didn't use the new theorem there. It's just a detour proof. You see, we did a couple of different triangles. And then down below, I'm not going to do this problem, but the last problem here, if you want to jot off to the side, I had 9 steps. And that's just a detour proof too. So it's nothing really new. Not much new today. Well, if you have questions, we'll be, meeting live on Wednesday. And of course, I'll have some office hours today too, in case you have some questions. But, detours and then the new right angle theorem, not really earth shattering.